class. Welcome to today's mathematics lesson. My name is Rose Mtimunye, and this lesson is proudly brought to you. I hope you are ready and excited for today's lesson. Don't forget, today is one of those lessons we are going to do a lot of calculations. So make sure you've got yours in front of you. And we are going to have some sketches to draw, so you can also make sure you've got a pencil and a ruler with you, right? There's a lot of working out. Your tools must be in front of you. There is no time to waste, okay? And I hope you have saved our number by now, 079 454 9535. That's where you ask us your questions and send us pictures of your work, okay? Today, we are starting a section on perimeter of 2D shapes. After perimeter, next week we are going to do area, and then we'll keep building up in all the sections that have to do with measurement. Remember, we started off with Pythagoras in our previous lesson. So Pythagoras was the foundation in order for us to do perimeter. Okay. All right. Let's look at the lesson objectives for today. By the end of this lesson, you should be able to use appropriate formulae and also conversions between units to solve problems and also calculate the perimeter of polygons as well as circles, okay? And your pre-knowledge from grade 7 and 8, you need to remember how to solve equations in general, making one variable the subject of the formula. All those things are important. You need to remember your properties of 2D shapes. In fact, our baseline is on the properties of some of the 2D shapes we've learned. Substitution and the theorem of Pythagoras, definitely. All right. This is your baseline assessment. It says list the side, angle, and diagonal properties of the following polygons, and you are given a square, a rectangle, and a parallelogram. All right. So let me just show you an example. This is what your table would have to look like, okay? So you have the name, and then your properties, and then you draw the shape. And when you draw the shape, make sure you fill in the properties as well on the shape, okay? All right. So for this activity, I am going to give you 5 minutes. So please make sure you do your best and you are done in that time. So you have 5 minutes. Welcome back, class. I hope you are now in the spirit of being proactive and you are definitely getting these questions correct. Am I right? All right. So send me your pictures. Let me see how you did on 079 454 9535. All right. Now let's look at the properties of a square. Okay, I did give you an example of what you would do here. So this is an example. You would draw your square. I have named my squares because it's easier for us to identify the sides that are equal as well as the sides that are parallel, and also the types of angles and things like that. Okay, right. So let's look at the properties, starting off with the sides. So the opposite sides are equal, right? Actually, all the sides are equal in a square, and then the opposite sides are parallel to each other, right? So that means AB is parallel to DC or CD, and it's also AD is parallel to BC, right? So those are the pairs of parallel lines, and then all the sides are equal. So AB is equal to BC and CD as well as AD. Okay, so I've got the mathematical way of writing the equal sides on under your polygon. So you can also just add those. Okay, so if you've got these, you get marks, right? But you can also just add the mathematical way as well, because that's generally how we would list the properties or use them when we answer questions. Okay. The interior angles are each equal to 90 degrees. Remember, in general, a quadrilateral will have interior angles that add up to 360 degrees. So in a square, when you add these 490 degrees, they will give you 360 degrees. So angle A is equal to 90, angle B is equal to 90, angle D is equal to 90 degrees, and angle C. Right. If we go back to when we were doing geometry, we would say that AB is perpendicular to AD and BC is perpendicular to AB, right? You still remember those, okay? But here we'll just state that all the angles are equal to 90 degrees for now. Yeah, then the next thing we need to discuss are your diagonals, right? So your diagonals would be the lines that go from from A to C, and also from D to B, okay? Those lines bisect each other. That means they cut each other in half, all right? And they do this at right angles, which means that the two diagonals in a square are perpendicular to each other, right? And also we are told that they are equal to each other as well. So that means that all the sides, if we call the center where they meet E, AE would be equal to AC to EC, and DE will be equal to EB. Okay, so all of them are actually equal to each other as well. Right, so that's how we would write that the two diagonals are equal. AC is equal to BD. Okay, here, if you've written it in points, you would get 2 marks here for saying opposite sides are parallel, and then saying all sides are equal. That would be 2 marks. For stating that each of the angles inside is 90 degrees, you get a mark. For saying that the diagonals bisect each other at right angles, just mentioning the word that they bisect would get you a mark. And then also mentioning that the diagonals are equal would get you a mark. So if you've got all of this, you already have 5 marks. Okay, so we are at 5 so far. All right. Okay, I am going to give you just 1 minute to quickly do your corrections here, and then we'll do B and also C. Welcome back, class. So let's look at part B of this question. We have to find the properties of a rectangle. Right, so this is what your rectangle would look like. It looks like a stretched out square, doesn't it? Okay. So now let's check what would be the same. The opposite sides would be equal, right? And the opposite sides would also be parallel to each other. Therefore, AB would be parallel and equal to DC, and AD would be parallel and equal to BC, right? That's what you have there. And the next part would be about the interior angles. The angles, each of them, angle A, angle B, C, and also angle D, will all equal 90 degrees each, right? And then all of them added together will still give you 360 degrees. Okay. Now we discuss the diagonals. The diagonals bisect each other and they are also equal, right? So that means they cut each other in half where they meet, and also all the sides, all the segments of these diagonals will be equal. So if we had point E there, AE is equal to AE, this side would be equal to EB, and we can also have DE equal to EC. That would tell you that the triangles formed when you draw your diagonals into a rectangle will be isosceles triangles because the two sides would always be equal. Okay, that's just something to keep in mind when our problem solving comes in later. All right, so here opposite sides are parallel and equal, 2 marks. Interior angles are equal to 90 degrees, a mark. Diagonals bisect each other gets you a mark. And also stating that the diagonals are equal gets you a mark. This is another 5 marks. Generous situation, isn't it? So far you should have 10. Well done if you do. If you have 5 up to 8, that's a very good try as well. If you got below that, I think it's definitely a good opportunity for you to be doing this baseline assessment because you're getting a good refresher on all the properties that you need to have when we work with perimeter and area. Okay? All right. I think we've had enough time to do our corrections, right? Let's look at the next part. Okay, these are the properties of a rectangle are almost similar to those of a square, so you definitely will be able to keep them in mind. Okay, now I'm going to do the properties of a parallelogram. Okay, this is what your parallelogram would look like, right? We also called it ABCD for ease of being able to write the mathematical statements necessary. So in a parallelogram, opposite sides are parallel and equal. I think you're seeing that this is a trend. Do you still remember we once learned that a square and a rectangle are actually special parallelograms, right? So that's what we are looking at here. That's why their properties always seem like they are similar, right? So AB is parallel to DC and also equal, AB is also equal to DC in that case. Then AD would be parallel and equal to BC. And then the next one, we look at the interior angles, right? We're finally moving away from 90 degrees. But now what we need to note is that the opposite angles are equal to each other. All right. So the opposite angles are equal to each other. So angle A would be equal to angle C, and angle B would be equal to angle D, right? But still, all the angles added together will still give you 360, just like they do in any other quadrilateral. Okay? And then the diagonals bisect each other, but they are not equal in length, right? So in this case, AC will bisect BD, right? But we can't just say any of the portions is equal to any other portion. So only DE would be equal to EB and AE would be equal to EC in this case. Right, do you notice the markings are different because now these sides are not all just equal to each other? Okay. All right. I'll just give you 1 minute to do your corrections here. Let me just give you marks. 2 marks there. Opposite angles are equal, gets you a mark. Diagonals bisect each other, gets you a mark. All right. So here we have 4 marks. Our total for this lesson would be 14 out of 14. So you can write down your total and then send me a picture on 079 454 9535. All right, I'll give you just a quick minute to do your corrections. Welcome back, class. Now let's get into perimeter of 2D shapes, right? That was a good refresher. We have all our properties in mind, right? Okay, so I'm going to move a little bit quicker with the basics that we should know, and then we'll get some more time when the time comes for us to do the activities. Don't forget, if you have any input about today's lesson, 079 454 9535. Send me that shout out. Let me know where you're from. Let's see who is with us today. All right. So to find the perimeter of any polygon, what you do is you add all the sides. Remember, perimeter is basically the distance around a shape, okay? So if we are given a shape like this one, it's just a skew shape, okay, like that. To get the perimeter, we'd have to add this length plus this length plus that length and that length, right? And then that would give us the perimeter. But what would be important is to make sure that if this length is given in centimeters and this one is given in millimeters, we convert one of these to be the other. So you go back to the question and see whether the question wants you to present your perimeter in centimeters or in millimeters. If not, if there is no specification, choose one of the units and then convert the other one to that one, okay? That's essentially what we do with perimeter. We just add the outsides of the shape, okay? Right, now I just want to remind you of the formulas. Some of them you will remember them. They're quite intuitive as well when you see them because you know that you're trying to add the outside of the shape, right? So an equilateral triangle, remember an equilateral triangle will have all sides equal and all angles equal, okay? So if you were doing perimeter, you would just add all 3 sides. It's the same as having 3 times one of the sides. So if this is 2 units, okay, then that means you would do 3 times 2 and you'd get your perimeter to be 6 units, right? It's the same as adding 2 plus 2 plus 2, right? That's what we are talking about here. Then a square is also a regular polygon, so all the sides are the same. Therefore, you can use 4 times the side. We can use the same formula as well for our diamond shape, which is a rhombus, right? So if you have a rhombus, you can also use that. Let me just draw it properly for you, right? Your rhombus would be like a skew shape. All the sides would be equal. Therefore, you can use the same formula as well to calculate its perimeter. All right. Right. We have 2 so far. We are going on to the next ones. All right, the next ones would be a rectangle and a right angle triangle. Okay, so a rectangle, we have length and breadth as the dimensions. Therefore, this means you know that the opposite sides of a rectangle are equal. So that means that's also a length. This is a breadth. As you can tell, we have two lengths and two breadths. That's what we would add. Hence, we have that. If you make it simplified, you get 2 times L plus B, and that would be your perimeter. With a right angle triangle, you would just add the different sides. If it's scaling like this, you just say A plus B plus C. Sometimes you'll be given a right angle triangle, but it will be missing a side, okay? Say you're given your right angle triangle, and you're given A and B, but you're missing the side. So you would use C squared is equal to A squared plus B squared. And that is your theorem of Pythagoras. The hypotenuse squared is equal to the opposite side squared plus the adjacent side squared. Okay, I hope you still remember that as well. Then you find the side, right? Once you found that side, then you go back to your formula for perimeter. We're going to do quite a few of those examples today, so do make sure you are ready for those. Right, we start already with our first example. This example is a type where the two questions are not exactly related, are dependent on each other. So that's good, because if you don't understand how to do the first one, you are able to at least do the second one, and your answer does not depend on the first one. Okay. All right. So it says examine the given diagram and then determine the length of CF and then determine the perimeter of ABCDE, which is the whole shape basically. All right. I'm going to do this one with you. So here what we start off with is to look for the length CF, right? Do we see where CF is? So CF is actually the height of the triangle BCD, this one. This is what we are looking for, okay? So we are looking for this side, this height, okay? So first things, we go and check our diagram. Hence, you're asked to examine it first. You notice that BD is equal to AE. These are opposite sides of a rectangle. As you can see, you do have all your right angles there. Okay. So if that's the case, BF and FD, as you can tell, that you are told that they are equal to each other, which means AE or BC is actually being bisected. Okay, it's being cut into half. So with that, that means we can divide 16 by 2, right? Dividing 16 by 2 will give us the values of these sides here, these ones. That's where we get our 8. Okay, so for BF and DF, okay, we've got those. All right, now let me rewrite them one more time. 8, 8. These are meters. Okay, then we now have to find the side. Do you notice that we actually have a hypotenuse? We have found a hypotenuse here. There's a hypotenuse BC. There it is. Okay, that's that. And then we have a side BF. Do you see your side BF? It's 8 meters. We calculated it together. And then we are looking for CF. Okay, so with those, we would use the theorem of Pythagoras. Don't forget, when you use your theorem of Pythagoras, to actually write what you have used. So BC would be equal, BC squared would be equal to BF squared plus CF squared. All I've done there, I've used the vertices of triangle BCF, right, to name the sides, right? So because I'm looking for CF squared, it means I must say the hypotenuse squared minus the side that is given as 8 meters squared here. So that's BC squared minus BF squared. And that gives you CF squared is equal to 10 squared minus 8 squared. And from there, you get CF squared to be equal to 36. But you're not looking for CF squared, you are looking for CF. So you need to square root both sides. When you do that, you get CF to be equal to 6 meters. When we square root distance, we only take the positive length. Distance is always positive. All right. One thing I need to clarify is you could have also used this triangle CDF. That would have also been acceptable because CF is a common side between triangle BCF as well as CDF. Okay. So now we have answered the first question. We're going to look at the next part of the question. It says determine the perimeter of the whole shape. So perimeter of the whole shape requires that we add all the sides. So that means this 17 meters will also be 17 meters that side. So you see now we have all the lengths. All right. Now we've got all the lengths. We can quickly go through them. So that means we are going to make sure that we add from 16 here, 16 plus 17 plus 10 plus another 10 plus 17. Okay, it's okay if you, in this type of question, you would choose to actually show the lines you're going to add together first, especially if you're given vertices. If you choose to say, I'm going to say AE plus DE plus CD plus BC plus AB, and then put the values, that is also acceptable. Okay, that actually helps you to keep track of which side do you still need to add. Then you should get 70 meters. That's essentially it. That's how we calculate perimeter. All right. Okay, so now you have an idea. I want you to try this activity. I'm going to give you just a quick 3 minutes to start this activity, okay? And then we'll see how far you are, and then I'll give you some clues and give you at least 1 more minute to finish it. All right, so you have 3 minutes. Welcome back. Let's see how you are doing so far. Did you notice that you cannot just immediately just add all the sides and say you found the perimeter? This is side missing. Do you see that? So the first thing you should have done was to find the missing side. That would have meant dividing the shape into a rectangle and a right angled triangle. Remember here, this is also a right angled triangle because we are able to use angles of a straight line. So those two must give us 180 there. All right. Okay. And then the line you've drawn will be equal to 3 meters. All you say is 11 meters minus 8 meters, right? That's where you get the space that's left to be 3 meters. Remember, this side is equal to that side as a whole. Okay. And then 4 meters, where did we get this 4 meters? We had to say 10 meters minus the 6 meters, right? So that's the distance from here, that's this distance there. That's 6 meters. So 6 plus 4 is where we get the 10 meters. Okay, so now we've got two values. We immediately recognize that if that is our right angle triangle in this corner, then this is our hypotenuse. Right, we'll call it x for the purposes of being able to solve. Right, this is what your diagram should look like. Don't be afraid to write on your sketches. It helps if all your information is on the diagram. Right, so for us to find the hypotenuse, we'll use the theorem of Pythagoras. We'll say x squared is equal to 3 squared plus 4 squared. So the hypotenuse squared is equal to the opposite side squared plus the adjacent side squared. And then we get that to be 9 plus 16. And then 9 plus 16 is 25. So when we square root x squared, we get x. And then we square root 25, we get 5 meters. So x is actually equal to 5 meters. All right. Do you have this? If you do, you get a mark. Then you get a mark for a statement and the reason. Okay. Now, what would have been your next step? Your next step would have been to find the perimeter. All right. Okay, I'm going to do it with you and I'll just give you 1 minute to do your corrections quickly. So your perimeter, you'll just add the sides. Now I left it as 10 meters there. If you don't use the 10 meters, this 10 meters, make sure you use 6 and 4. So you'd use the 4 meters and the 6 meters. Don't make the mistake of adding the 10 meters and the 4 meters. All right, because now it's a different allocation completely. Okay, so 10 plus 5 is 15. Then we keep adding 8, 6, and 11, and we end up at 40 meters. That would be the perimeter in this case. Right, so I'll just give you 1 minute to quickly do your corrections for the perimeter, and then we are going to look at another example. You'll have 1 minute. Okay, class. So now let us look at the circle, right? I'm just going to give you a quick refresher. Remember we did this in grade 7, right? So just a refresher of the parts of a circle. Well, the ones that are important for us to understand perimeter anyway. So the perimeter of a circle is actually called the circumference. So that would be the distance around the circle. All right. That would be also known as C. And then the middle of that circle would be known as the center. Right, now, if you draw a line from the center to the circumference, that is now called a radius, right? That's the distance from the center to the circumference. Okay. But let's say you draw a line from the circumference to the center or through the center to the other side of the circumference, and that would be now known as a diameter. Okay, so that would be the distance from one side of the circumference through the center to the circumference again. All right. You need to know this because we are going to use them. Do you see we use a C for circumference, R for radius, and D for diameter. Okay. All right. You've got this. You still remember this, right? Yes, it should just pop up when you see it. All right. Now let's discuss the formulas that are associated with circles. Starting off with the perimeter of a full circle. So the perimeter of a full circle will be 2 pi r. All you need to do here is just quickly note down the formulas. All right. If you are given half a circle and it's closed, so a semicircle that is closed, you would use half times 2 pi r. We always go back to the formula for the full circle and then have that full circle or divided by a quarter, a third, depending on the size of the circle we are working with, right? Then plus the diameter. Do you see that? Your diameter is actually 2 radii, because this is actually a radius and a radius. That's also 2r. You can also say half times 2 pi r plus 2r. Okay. If the circle is open, then you don't need to add the diameter. I've used dotted lines there. So that means you would just find the distance around the curve. So it would just be half 2 pi r. Now, if you get a quarter circle that is closed, you would use a quarter times the perimeter of this full circle plus the 2 radii, this radius and that radius. So you'd add them. And you know this is also the same as a diameter. It's just easier to recognize the 2r because you see the radii in this case. Okay. A quarter circle that is open, you do not add the 2 radii, you'll just have a quarter times 2 pi r. Okay. Most important formula for you to write down is 2 pi r, that is the perimeter. Then everything else is based on the type of shape you are given. Right. This is our first example. It says calculate the perimeter or circumference of the circle below. I am going to do this one with you because it's quite straightforward. Right, we're given this 15 centimeters. What does it represent? It represents your radius. So your radius is equal to 15 centimeters, right? Okay, and we've been told to use pi as 3,14. Now think about the formula. What's the formula? The formula for perimeter of a circle is 2 pi r. That's the circumference. We already know what pi is when we know what r is. We just substitute those. But some of you may use the formula for pi and a diameter, pi diameter. That's also fine, pi times the diameter, because 2r is also related to the diameter. It's also acceptable, okay? Pi times d. All right. So we substitute the 15 centimeters and we substitute the 3,14 for pi. You use your calculator, you get 94.2 centimeters as your circumference of the circle. So that's the distance from this point all the way around back to that point. Okay. All right. So this is when you're just given a straightforward circle. But we know life is not that simple, right? So usually you would get something that looks like this. This would look like one of those French windows, you know, nice, beautiful window in a big mansion, all right? Or in a church, right? This is what you'd have as the outside structure of that type of window. It says determine the perimeter of the given figure. Correct to 2 decimal places, and pi is equal to 3,14. Right. I am going to actually give you time to do this on your own. I'd like for you to try it. All right. So I'll just give you quick 4 minutes to do this activity, and then we will discuss it together. Okay, class, let's see how you did with this one. Right, don't forget to send me those pictures on 079 454 9535. So here, you should have recognized that you have a combination of a square, an open square, and an open semicircle put together, right? So first, those markings mean that all the sides that have that same marking are equal. So You have 10 centimeters, 10 centimeters, and 10 centimeters, right? That also means that even the dotted space there at the top would also be 10 centimeters. Why do we need to know that? We need that because we need half of that distance to be the radius, and the radius in this case will be 5 centimeters. Right, so we've got our radius, right? What's the next part? The next part is for us to formulate a formula. So we know that for the perimeter or the circumference around the curve, we would use the formula for a full circle divided by 2, or half times 2 pi r, right? Already when you look at it, you can tell. Let me just show you. A half times 2 pi r over 1. And you see that these 2's will cancel and you'll be left with just pi r. Okay, so you would add the 3 sides to get the perimeter plus pi r. And that would give you 10 plus 10 plus 10 plus 3,14 times 5. And you get 45,70 centimeters there. Right, so if you have some type of formula to help you find the perimeter, well done. Correctly substituting also will get you a mark. Then finally, having the perimeter in the correct units is very important as well. Centimeters. All right. Okay, so I'll just give you 1 minute to do your corrections for this part. All right, class. So let's look at the next activity. All right. For this activity, it says Joe is training for a race. She runs around this track, right? So there's the given track, and you're still going to use pi as 3,14. Show that she needs to complete at least 13 laps to have run 5 kilometers. All right. So because we are running out of time, I'm going to do this activity with you. All right. But I do need you to participate in parts of it. So I will give you some parts to do. All right. Let's start off by understanding what the question is telling us. So they are telling us that this is a track. Think of the track you have at school, your stadium or your sports center, right? And this is what the track looks like. So Joe's training for a race. She runs around this track. So running around this track would mean that we only have to look at the distance on the outside of this shape like that. Agreed? Right. So that means the 51 meters would not be included when we check the distance that she has run. Right. But what would we do with the 51 meters? We'd use it to find the radii, right? The radii. So we would have to divide 51 meters by 2 to get our radii. Right. Okay. And in this case, our formula for perimeter would be equal to the circumference of half a semicircle plus the longer side of this rectangle plus the other longer side of this rectangle. So that's 2 of them because these are equal, plus another semicircle. All right. Now you notice here you could have, because the circles are actually identical according to these measurements, we could have actually just used one circle. Instead of having half 2 pi r plus another half 2 pi r, we could have just used 2 pi r, right? Think about it. Half plus half gives you 1. So we could have just used one full circle for this part. All right. So you can just have your formula as 2 pi r and then add 2 times 120. That will also be acceptable. Okay. Right. So once we have our formula, it would be quite easy for us to substitute into it. So we are substituting a half. So here, what you see, the half and the 2 didn't disappear. Remember, half times 2 over 1 will give us 1. Hence, we don't have any 2's there, right? So we substitute and we get 3,14 times 25.5. Where did we find 25.5? Yes, I hope you still remember I showed you a hint here. It's 51 divided by 2. Okay, that's where we get 25.5. All right, so you've got that. Okay, then we add 240 and then we do the identical semicircle on the other side. Then we get the perimeter of this track to be 400,14 meters. All right, I haven't rounded off to a complete number because there's still more work for us to do. Okay, now we've calculated one lap. Basically, that's what we've done. We've calculated one lap. Now, the option here would be for us to find how do we get to 13 laps? What would we have to do? And what do we do with those 5 kilometers? Do you see there's a lot of things for us to figure out here? All right. So the first thing is to make sure that we understand that 5 kilometers and meters, those are two different units. We must convert one of them to be the same as the other. So there's 1,000 meters in 1 kilometer, right? So we start there. 1 kilometer is equal to 1,000 meters. So that means 5 kilometers is actually how many meters? 5,000 meters. Yes, we've got that. And well done. The next part is to divide the 5,000 meters by the perimeter of one lap, right? And then that will give us the total number of laps in 5,000 kilometers. Do you understand? Right. So when we divide 5,000 kilometers by 400,14, we get 12 and a half laps. That is the total number of laps in 5 kilometers. Now the question says, show that she needs to complete at least 13 laps to have run 5 kilometers. Right. Now a full lap would mean that we would need to have 13 laps there, right? So definitely, if she runs 13 laps, she will have run more than 5 kilometers, right? So at least 13 full laps would give you 5 kilometers. Actually, you'd have run more than 5 kilometers because 12 and a half laps would be 5 kilometers. Okay. So essentially, we are saying we don't want her to stop when she gets to 5 kilometers. She must just continue and finish the lap. Right. So this is how you would approach this type of a question. I hope it just makes sense. Okay. So most of the time in your exam, you'll find these types of questions where you need to apply your thoughts, right? And then sometimes with the circles, then you would find maybe one or two where you just need to calculate the circumference of a complete circle. All right, so this is your homework. It says determine the perimeter of the given trapezium in centimeters. I'm going to ask you to please take a screenshot, a picture, or just quickly draw the shape. All right, I'll just give you 1 minute and then we will go see if we have questions. Okay, so I hope you've taken a picture. Do share it with your classmates that still need to get this homework right. Now, I currently do not have any questions, but I do trust that that is because you've been so busy writing and doing what you're working out, right? And I take it without any questions, you understood what we did today. So yay. Right. But do save our number for future reference 079 454 9535. Now we are going to move on to our summary. Right. The first thing we discovered was that we definitely need to remember how to use our theorem of Pythagoras, right? Because when we have sides that are missing and we divide the shapes, we end up needing to use the theorem of Pythagoras. So that's a squared plus b squared is equal to c squared, right? Don't forget that we use the same formula for the perimeter of a square as well as the perimeter of a rhombus. Okay, so that would be 4 times the side. All right, and then the perimeter of a rectangle is either 2l plus 2b, or you can factorize it and get 2 times length plus breadth. Then circumference of a circle is 2 pi r. All the other formulas we discussed under the circle are simply derived from 2 pi r, because we either half 2 pi r, find a quarter of 2 pi r, or even a third, depending on the shape you are given. Okay, so make sure you have these main formulas for your perimeter in mind when you get ready for your exams. In the next lesson, we are going to be looking at the area of 2D shapes. We're still going to look at both polygons as well as circles. So I think today you've gotten an idea of the amount of work you're going to do. There's also the calculations that you will need to be prepared for. So do make sure you come with that intention to be up to par. All right. Thank you so much for joining us today. My name is Rosen Timunya, and this lesson is proudly brought to you by the Gauteng Department of Education. Do join us next time.